Okay, this is a YY circuit. So you see this is a YY circuit. Okay, so from this circuit, we have a phase voltage of 110 volt. Okay, so reference of a BAN is a 0 degree. Okay, since as we assume as it is a positive sequence. Okay, so for VAN is 0 degree. So VBN will be minus 120 degree and VCN is plus 120 degree or equivalent to minus 240 degree. You can also put here as plus 120 degree volt. Okay, so calculate the line currents and line voltage for this YY system. So as you can see, there is a two value of impedance, which is line impedance, okay, line impedance and load impedance. Okay, so you have to total up this line impedance and load impedance as it will obtain the load, the Y load. Okay, so ZY is equivalent to Z line plus Z load. Okay. Okay. So since Z line is equals to 5 minus J2 and Z load is equivalent to 10 plus J8 ohms. Okay. Then ZY will be 15 plus J6 ohms. Okay. Okay. So to calculate the line current, we may replace the YY circuit, the three wire circuit, to a single phase equivalent circuit. So from previous slide, okay, we know that the VAN is 110 volt with 0 degree. So calculate with ZY, okay, connected to ZY 15 plus J6 ohm. Okay, so line current IA, okay, using Ohm's law is VAN over ZY. So since VAN is equivalent to 110 volt, okay, over 15 plus J6. Okay, so IA, you will get IA is equivalent to 6.81 with minus 21.8 degree ampere. Okay, since the source voltage are in positive sequence, so the line currents are also in positive sequence. So to get IB, okay, as I mentioned earlier, the magnitude of IB is equal to magnitude of IA. So the magnitude of IB is the same as IA, which is 6.81, but the phase angle for IB is minus 120 degree out of phase. So you have to calculate the angle for IB, which is minus 21. Okay, you have to refer to IA, angle IA first. Then you have to minus 120. Okay, so you calculate, you will get minus 141.8 degrees. So the angle for IB is minus 141.8 degree ampere. So similarly with line current IC, magnitude is same at 6.81. Okay, so the angle you have to plus minus plus 120. Okay, plus 120 from angle IA. So this one you will get 98.2 degree ampere. So 98.2 degree. So IC is equivalent to 6.81 with angle 98.2 degree ampere. Okay, this is for line current. Okay, for line voltage, okay, we know that the line voltage is equivalent to square root 3 times V peak with difference angle of 30 degree. Okay, so for VAB, okay, line voltage consists of VAB, VBC, and VCA. Okay, so VAB is equivalent to square root 3 times VAN with angle 30 degree. Okay, since VAN, okay, we have a 0 degree. Okay, so you have to plus with the 30 degree. Okay, so VAB equivalent to square root 3 times 110. Okay, actually it is you have to insert the phase angle for the VAN to 0 plus 30 degree. So this one you will calculate, you will get 190.526, okay, with angle 30 degree. Good. Okay. So to calculate VBC and VCA, so you don't need to calculate the magnitude because the magnitude is the same. So VBC is equals to 190.526. So you have to calculate the angle only, since the angle for VAB is 30, okay, and the circuit is a positive sequence. Okay, for a positive sequence, we have to minus 120 for VBC. So the angle for VBC is minus 90 degree. Okay. So similarly for a VCA, magnitude is same. Okay. And the angle 30, you have to plus 120. So the angle for VCA is equivalent to 150 degree. Okay, we move to another example of a YY circuit. So for this circuit, calculate the line voltage and line currents and assume a positive sequence. Okay. So this figure we just have a load impedance only. Okay, so ZY will be 6 minus J8. So first thing we have to calculate is line current. So we use a single phase equivalent circuit. Okay, with VAN is equal to 440 with 0 degree volt. Okay, connected to ZY, which is 6 minus J80. Okay, we will calculate the line current IE. So IA, okay, is equivalent to 440 0 degree divided by the load impedance, sorry, the Y load impedance 6 minus J8. Okay, so this one you calculate, you got 44 volt with 53.13 degree ampere. Okay, so as it is a positive sequence, so IB with the same magnitude of IA 44, so 53.13 minus 120 degree, because this one is because of positive sequence. Okay, if negative sequence, you have to plus 120 for IB. So for IB, the angle for IB is minus 66.87 degree ampere, and IC is equivalent to 44. Okay, with the angle 53.13 plus 120. Okay, then you will get 173.13 degree ampere. This is a value for line currents IA, IB, and IC. For a line voltage which is VAB, VBC, and VCA, okay, we know that the formula is square root 3 times VP with 30 degree. So VAB equivalent to square root 3 times 440, 0 plus 30 degree. So you calculate, you will get 762.102 with 30 degree volt. Okay, then as a positive sequence, BBC, okay, you just write down the magnitude of line voltage. Okay, then you just calculate the angle for VBC. Okay, as a positive sequence, you have to minus 120. So you will get minus 90 degree. Okay, VCA, the angle you have to plus 120 degrees. So for VCA, the angle is 150 degree volt.